Hi everyone, you're going to learn the last step for proofs, and that's proofs with CP6. So just a quick reminder about what we can conclude about congruent triangles. This was back at the beginning of the chapter. Anytime we know two triangles are congruent, we can say that all of the matching pieces are also congruent. And that's what this part of the proof allows us to do. So it's always typically the final step. And I'll show you a little bit about that in just a second here. So CP6, it stands for corresponding parts of congruent triangles are congruent. Actually stands for. You don't ever have to write that whole thing out. You could always write CP6, even on the regions. It's allowed. It's standard geometric notation. Here is what it would look like in a proof. We'll start the proof as we would. So I'm going to label my givens. I have two parallel lines, so I know I'm going to look for those alternate interior angles after I put that given into my proof, which are there and there at B and D. Okay. I'll put that in. Alternate interior angles are congruent when lines are parallel. Again, this is what we've been doing. I'm going to put my other given in. BC is congruent to DC. Mark that on my picture. That was also given. I'm out of givens and I don't have any other vocabulary, so I look for vertical angles or reflexive property. I see my vertical angles at 3 and 4. Again, as long as you label them, that's allowed. So I put angle 3 is congruent to angle 4 because my vertical angles are congruent. Now, this is where it changes. I haven't proven what the proof is asking yet. I haven't proven segment AC congruent to EC. You're going to need to do a triangle statement first. That's going to happen. So you have to put that congruent statement down. So triangle ABC, you could have called it any triangle you wanted to. Now you have to pick the corresponding letters. So triangle EDC, I say that those are congruent because of angle side angle, as we've done in the past. This extra step, now that I have congruent triangles, I can say all the matching parts of them are congruent. That's what CP6 allows me to do. So after I have those triangles congruent, I can prove that AC and EC are congruent because they are congruent parts, or excuse me, corresponding parts of those congruent triangles. That's where that CP6 step comes in. It's at the end of the proof after you've said two triangles are congruent. You're saying, hey, that means these pieces are also congruent. Here's another example. So again, we're going to start like it's a triangle proof. So I'm going to mark AC congruent to CE. I'm not trying to prove triangles congruent. I'm trying to prove angle B and angle D. So AC is congruent to EC, so are BC and DC. That's my given. I have no vocabulary, so I have to, after labeling my diagram, I have to look for those vertical angles or reflexive property. In this case, it's the vertical angles. So vertical angles are congruent. I now have enough to say that the triangles are congruent. So I say triangle ABC is congruent to triangle EDC. Remember, you're always pretty much looking for that first. And that's because of side angle side in this case. Ooh, looks like I have a typo in there. Sorry. Let's fix that typo. Copy and paste it without changing it. That's a side angle side. And now that I have that, I can use CP6 to tell you that these other parts out here that aren't labeled but are still corresponding parts because of B and D, just in case you weren't catching on to that. Angle B is congruent to angle D because of CP6. They're corresponding parts of congruent triangles. All right, in the next one, AC bisects angle DAB. So I find angle DAB first, and I mark those bisectors. So that angle there that I'm going to put a 1 and a 2 in, it gives me those two angles are congruent because a bisector cuts an angle into two congruent parts. I go to my next given. I label it. I have no vocabulary there, not much more I can do with that right now. So I look for the reflexive property of vertical angles, which I have the reflexive property, so I put that in my proof. I now have enough to prove the two triangles congruent, so I'm going to do that with SAS. And then that last step is that CP6. I'm looking to prove those two angles, angle B and angle D congruent, so CP6 gets me there. So it's all the stuff we've been doing with an additional step. Now we know how to prove something after that we prove triangles are congruent. All right, number 4, C is the midpoint of AE and BD, so that's a twofer. So I have my midpoint there, I label, and then I write. So AC is congruent to CE, a midpoint cuts a segment into two congruent parts. And then just so you know, if you're ever going to reuse a given like we will in this case, or excuse me, a reason, you can just say reason. Oh, my things are, I'm just going to show you the whole thing. my animations were off. So you can, in step 3 here, you can just say reason 2. All right, so reason 2. Or you can rewrite midpoint cuts a segment into two congruent parts. So then on number 4, I'm saying the triangles are congruent because of SAS. This last one is a little bit different because I'm trying to prove a vocabulary word. So I have to ask myself, what parts will help me prove AB parallel to DE? And again, that's where I look for those alternate interior angles. So I picked B and D. You also could have picked A and E, but that's what I chose to use when my corresponding parts of congruent triangles are congruent. And then it's one additional step. So now that I have that, I can say, hey, these lines are parallel because if I have congruent alternate interior angles, the lines must be parallel. So it's one additional level of what you could do with a proof. That is it for this video. Have a wonderful day, and I will see you in class.